Hi, I'm RK here and welcome to Unreal Engine 5.4 in the release version. Last few videos we worked with preview version, some things changed, I'm not gonna talk about all of them, but I am going to talk about one. But it's not the topic of this video, it's just a side subject I'm gonna just mention quickly, because it's kind of related to what I'm going to be talking about today, but it's not the main part. Okay, so what is the today's topic? Well, it's data management, and this is a topic I have seen kind of mentioned, not a lot but a little bit, on internet, and actually somebody mentioned this in the comments of my 5.3 updates video, and this guy mentioned, data management in state trees. And you can, kind of read or just go to that video, watch it, and then read the comments and see what you think about them, about those comments. But images, the conversation were about how do you manage data in state trees, right? And one kind of way I suggested that we could go about this was using a separate U object, or just object, or maybe a different kind of object you derive from U object, and just store data there. So the principle would be like, you make a blueprint class, you make just an object, you call that object BP store or whatever, and in that object you just store some variables like test boolean, test float, and so on and so on. And in the actual state tree, you would just probably make a global task, and in that task you could probably make a new state tree task, right? And in that task you'd say st init, and in that init on enter state you would just create object, or construct rather, construct. I can't write today. Construct object from class, pick that store class, right? I can't even hit it. Store, BP store, right? And just, promote to variable, put that to an output. I need to focus. Output category, and then you would put it here, and now we have store as output. And then if we wanted to make another state would be like move mave to, yes, move to, and in that task we would add, let's say, move to, and we could just pass that store to that task and maybe store some variables in that object, right? So it's like one of ways you could go about storing data. And of course, this is all an alternative to what you would normally do if you would want to store some data, because the very straightforward and the most straightforward way would be to go to just class of the character you are using the state tree on, and just store variables there. And then when you use that task, you just context actor, right? Take that context actor, put a class there, and just take it out, and just set variables, right? But the reason we are talking about alternatives is that maybe we don't necessarily want to store variables straight in that actor, right? So we are kind of chilling today and discovering a few different ways we could go about doing this. And yeah, we're just gonna chill and see what else we can do. So my option, well, before we go to the next part, I of course encourage you to watch my video about state trees, last state trees video, where I actually made those state trees. I showed linked assets, I showed some other updates, colors and stuff, of new stuff that came from Unreal Engine 5.4 in preview version. And you would know why do I have those assets and why they are structured like that. And okay, moving on. How do you store data? Well, either an actor class or what I just showed you, so a new object that you can just init in the state tree, or you could do what this guy did. And this guy did basically, he went back to the blackboard. And blackboards, if you are not aware, blackboards are used or were used, or both, with behavior trees. So behavior trees are, I would say, but you can like not agree with me, it's a legacy version of doing AI in Unreal Engine, because I consider state trees to be superior and a next-gen version of behavior trees. And behavior trees traditionally used and still use, if you want to use behavior trees today, blackboards. And blackboards are types of assets that are kind of tied to behavior trees, but not necessarily. I mean, you can not tie them, but you would usually do that. And you would store data there. So blackboards do look like this. So you just go to Blackboard, and in Blackboard you have this, you have keys, and you can add more keys with a vector key or maybe a name key, right? You name all of that however you want. And then in Blueprint you would just go set Blackboard, or maybe not, like we probably need to get Blackboard first. Excuse moi for not being a pro at blackboards and behavior trees. I kind of like didn't do much of AI before state trees, so I didn't look at behavior trees that much. But you would get a blackboard, and then you can get value as class, bool, enum, float, int, whatever, or set value as float, and And whenever you select that node, so set value as class or bool or whatever, then you pass a key. And that key corresponds to whatever is here. So if we want to change that vector key, then we would pass a literal name or whatever variable we want, and then just type vector key, right? And that vector key, well, this doesn't make sense, of course, because you would want to set value as vector, right? And then just, pass whatever vector you want. And all of that is stored in the blackboard. So how do we use blackboards with state trees? I mean, you kind of don't really, but you still can. And if you know, if you want to experiment and try anyway, then go for it, read that comment. I think it's a great idea if you want to work with blackboards. And this guy used actually AI controller to hook state tree to it, and then kind of do a few more steps to achieve that purpose. And one thing new from state trees 5.4 in the release version was actually a new schema. So when we go to artificial intelligence state tree, now, in addition to state tree component and probably gameplay interaction, yeah, this is also a schema, we have state tree AI component. And if we pick that AI component, Now we can make a different kind of state tree assets, and those assets, I already made one here. It's this state tree AI component schema. When we open this, we have AI controller class. So this state tree asset is basically guaranteeing an access to AI controller class. So probably what this guy did would be easier now with the 5.4 release version, because you have direct access to AI controller and you can do more stuff. So yeah, that's the third way you can store or manage data in state trees. And I guess one thing I wanted to show you is, this. So description for state tree AI components is just, it guarantees access to an AI controller and the actor context value can be used to access the control pawn. Right, so just, expanded version of state tree asset. The normal asset we had until this point, right? It's just, we added one more variable. And this gave me an idea, like how else could we manage data and store some variables if we don't want to use a Blackboard, and if we don't want to store variables straight in the actor, and we don't really want to play with constructing a new object. So I was thinking like, hey, okay, we have a component, a state tree AI component, we have this a class, AI controller class, we can have a context actor class, and all of that is basically stored in a component we have to add anyway to use state tree with any actor. And these guys, so Bernardo, it works only with AI. Right? So if we hook a Blackboard and we try to use the Blackboard with AI controller, then we are only stuck with AI, right? And if we wanted to store or manage data in actors other than AI, then you would need a different approach, right? And it's like no longer viable. And you still could store data in the actor class and do this approach, but I think I have something better. So my idea is to store data straight in that component. Right? So just use it as a Blackboard and the state tree in one component. I mean, it's probably controversial. Like, you could disagree with me and say, we need to decouple the logic and the data, right? And you would be right in some way, right? But I don't necessarily like it, and I think this way has its upsides. So how do we store data in that component? First of all, when we make a state tree component, right, we type state tree like this, and we also have state tree AI, because I didn't tell you that, but to use that new schema, you have to use new component or it just doesn't show, right? We have AI base follow ROM, but we don't have STAI base, which is state tree AI component schema, and we don't have, of course, this, because it's gameplay interactions from my previous video. So yeah, you have to add a new type of component to use it. And when you do add, well, any of that, it's basically this, right? You actually cannot get that asset, you cannot set it, and you cannot do anything meaningful to that, because all of that is stuck with C++. And if you know me, then you know I'm not a huge fan of C++, so I prefer to do everything in blueprints. But sometimes C++ is inevitable, so I went today to C++ and I made a new class, because to actually expose what I want to expose to blueprints, we have to do this in C++. So what did I do? I made my own state tree component. And that state tree component is actually exposed to a blueprint. So yeah, my idea is that we have a state tree component and then we have variables that actually just store data. And they are structured in a way that it's kind of similar to Blackboard. So we have maps, we have like vector map, we can do float map, or we can do even make a separate object, which is BP store, and then just construct it when the state tree component is activated, which is, I mean, if you want to do this. This is just, you know, rambling, thinking aloud kind of thing, experimenting. So there is a lot of way you can improve that system, but yeah, let's just do this right straight in the straight state tree component and see how this works. So I added just a map vector because I don't really want to add all of those things that are in the Blackboard because yeah, we just want to test it, right? See if that works. And how did I make that state tree component? Because if you go to Blueprint class and you type state tree, then this won't show. All of that won't show. And even if it does, then you can't make a blueprint out of this. But I made my own child class of state tree component in C++, and then I made it blueprintable. So I made a state tree component that is actually a blueprint. And it's actually a super straightforward to do. You don't have to be a master at coding. I'm just gonna, you know, jump straight into the Visual Studio, show you how to do this and how to actually expose some new functions that will or will not, but probably will be useful to you in a later date, probably. So let's jump into Visual Studio. And this is how my project looks. So we have that MRK state tree component, which you can see here, or rather here, because that blueprint state tree component is a child of MRK state tree component, and that is a custom C++ class I made here. And that is, of course, inherited from normal state tree component. And to actually compile it and use it, don't forget to add very important modules, which are written here. Find your build CS and add those two modules. Otherwise, yeah, your project just won't compile and you will be stuck. So I was actually stuck with this for a while because the error messages are not very helpful sometimes, but yeah, you just need to add those modules and you are good to go. And then what you want to do, I just did it in .h, but you can of course implement this in .cpp, whatever you want. And those two functions I added here is get state tree asset and set state tree asset. So now from blueprints, we can just, you know, take that component. We can now get it and get state tree asset. And now we can do something with it. Maybe we can kind of save it. And we can, of course, set state tree asset. And yeah, just pick whatever you want. So yeah. Very, very, very nice, very cool. And when you do that, make sure to mark this class as blueprintable, and all of that I just copied from use state tree component. So just, you know, copy this and paste and just add blueprintable, so you can make a blueprint class out of that component. And then those functions, well, I just made this pure, and this is callable, and you might wonder why this is get mutable state tree. It could probably work with just get state tree, but get state tree returns a constant state tree. So you'd have to add const here, and maybe it will have some problems later. I don't know, but mutable is just a straight pointer, so I decided to go with this. And this is all of the code, right? You just make a new C++ function, do this, right? You can zoom if you want, rewrite it, whatever, and compile and you're good to go, right? And then you make a new blueprint class. You write state tree, BP state tree component, select, and you make your own component. And now you can have variables in that component. And whenever you want to store something, you just go to whatever. You can do this in STT as well. So let's go to init, whatever. And from context class, we can just get MRK, or how is it called? BP state tree component. And state tree component. It was down here. I don't know why it didn't show before, but okay. We have that BP state tree component, and then we just take map vector. And we can store whatever vectors we want as keys and values in that map variable. Straightforward and simple to use, and I think will be quite powerful if you find a nice use for it. So, what would be my use for it? Okay, I hear you ask, and a very good question. I'm gonna answer it right away because I have prepared an example for you guys, and that example involves nothing other than that map vector. So, if you remember in our, well, let's just maybe close all of that. In our ST AI base, we have two states, right? We can roam, we can follow. All of that is dependent on the bool variable that we have in, or we should have in BPAI, but now we don't for some reason. I don't know why. Let's quickly maybe check. Yeah, that actor follow kind of disappeared. Let's make it again follow and mark it false. We compile, and yeah, we are good, kind of. Let's just reattach this. Where is that follow here? Okay, follow, and here it is good. So in that AI base, we just go to follow if the actor is going to be followed, roam if not. And in AI roam, we have that STT move to. So in my original example, it was just 0.5, and it would also use smart objects, but for purpose of this video, I just made it 1, so it is always picking that state. And that state is using STT move to, which we will use for our example. So what is the current purpose of that STT move to? Well, the purpose we want to show today or experiment with is, well, we find a random position in the reachable radius, or rather reachable point in radius, and then we go to that point. So that's the OG example. And now with this kind of, data management, we can save those locations. Sorry, I'm kind of like dry throat. Excuse-moi. Okay. We can store those values and maybe show a history of visited locations. Like, this is probably something that could be useful in a real world scenario, right? So let's do this. And in our STT move to, this is the same code we saw in the UE5.4 preview updates video, so you can just watch that, but it's really not complicated. Get the location, select if random destination true, then yeah, get that. And I move to, and then what we can do is just get that state tree component, take the map vector and add a value to that. For key, I'm just using time. So this is BP utils and it's using UTC now to make a basically unique key, because I don't really need to name those values. So it could just be an array instead. But yeah, we are going with a map. So I just made, a key that is always unique. So we add that position to a vector, and then when we, on success, it's all on success, then we got all of the keys and we loop through them and we make a draw debug line, which takes one position and the next position. And this is basically how you make a data history. So now whenever the character moves, it stores a position in that map, and when he gets to his location, it just replays all of his visited locations and draws nice debug lines. So yeah, that's the example for this data management method, and there are probably many more that you could do, but this one I think is pretty cool and will work with AI and non-AI actors, and you can just, forget about initializing anything. You can just, add this, and whenever you want to store something, then you just take that BP component, store it in the map, forget about it. And it's all initialized with the stage 3 component, so you don't have to remember anything. I just add stage 3 you would normally add, and it already comes with maps that you can use to store values. So yeah, that's my little idea. I hope you enjoyed, and tell me, what are your ideas on how to manage data in state trees? So that's it. Drop a like, drop a comment, drop a sub, of course. Most of you, like 95%, are not subbed, and you should be subbed because I made banger videos like this one. And see you next time. Bye bye.